the first humans living on Mars in this way. To start today's video, we need to know if you are genuinely interested in Mars and eager to one day settle on the red planet. Please answer a quick question for us. If you are standing on the surface of Mars, which planet from the Sun are you on? A, third, B, fourth, C, fifth, D, sixth. Write your answer in the comments section below the video. Now, let's get back to our journey of exploring Mars today. If humanity were to choose to live on another planet besides Earth, it would, of course, be Mars. This is the planet with the most Earth-like geological structure in the solar system. It has an atmosphere, albeit very thin, polar ice caps at both poles, subsurface water, day and night cycles, and an axial tilt conducive to creating seasons. For centuries, these ideal conditions have sparked the idea of settling on Mars, and today, the prospect of living there is no longer science fiction. If you plan to move from Earth to Mars to live, you will need to calculate all the costs associated with space development, scientific research, rocket technology, and more. The distance from Earth to the surface of Mars is approximately 401 million kilometers. Based on the actual costs of recent space exploration missions, we can estimate the expenses required for humanity's relocation to the red planet. Just the cost of NASA's Curiosity rover mission to explore Mars consumed a budget of $2.5 billion. According to estimates from leading global space agencies and companies, the cost of reaching the red planet is no small sum. NASA estimates it would cost approximately $100 billion, while SpaceX, led by billionaire Elon Musk, offers a cheaper estimate of just $36 billion. If you decide to move to Mars, it means you must prepare everything necessary for living there. The first task is to set up cabins for human shelter, similar to building a house on Earth. According to calculations, the cost of a cabin with a volume of 120 cubic meters constructed by NASA is approximately $267 million. If you choose SpaceX as the contractor, the cost is more affordable, around $150 million. In addition to housing costs, the expense of food and drink is also significant. You cannot simply rely on available water, because Mars has no accessible water sources. The amount of food and drink required for one adult per day is estimated at 3.7 liters of liquids and 2 containers of food, equivalent to energy intake between 1,000 and 1,500 kilocalories. According to NASA, the cost of transporting food and drink from Earth to Mars each year is about $42 million. SpaceX estimates this cost to be around $13 million. These are the projected initial costs. Once settled and beginning life on Mars, we will need to start cultivating crops and finding water sources for direct use there. However, you cannot explore and develop Mars with bare hands. Instead, we will have to transport machinery and equipment to support farming on Mars. The estimated cost for this is around $15.4 million according to NASA, or $4.6 million according to SpaceX. If you want to make a phone call to share your rosy life on Mars with loved ones on Earth, calculations show that a 1-minute call will cost approximately $210. Sending an email of about 57 kilobytes will incur a similar expense, especially if you want to watch popular videos on YouTube. You'll need to pay around $37 for a single video. According to NASA, the total necessary costs are estimated at $121 billion, while SpaceX offers a lower figure of $48 billion to support 15 people living on Mars for 1 year, with each individual having their own rocket for the journey. However, if you have nothing but money and decide to pack your belongings and book a rocket to move to Mars, Ensure your safety by reviewing the potential risks of such a journey. Being so far from Earth, a trip to Mars will take 6 to 9 months. The distance between Earth and Mars varies due to the elliptical orbits of the planets, meaning there is only a short ideal period when Mars is closest to Earth to begin the journey. This greatly complicates logistics compared to lunar exploration, where rescue missions or backup plans can be supported from Earth or an intermediate space station. On a journey to Mars, such options do not exist. During the long journey from Earth to Mars, astronauts must face one of the greatest terrors of space travel: solar flares. These are the most powerful emissions in the solar system, equivalent to 100 million thermonuclear bombs. Earth's magnetic field can shield you in orbit, but when venturing deep into space, such radiation could render survival impossible beyond a few days. A call between Earth and Mars can take anywhere from 4.3 to 21 minutes to connect, meaning that sending a message and receiving a response could take up to 42 minutes. Beyond the role of social interaction, maintaining communication during space travel is essential for astronauts to receive technical support and ensure safe landings. Assuming the journey to Mars is successful, landing on the red planet could be the most challenging step. When describing the experience of landing on Mars, a NASA official referred to it as 7 minutes of terror. Probes like Spirit and Opportunity entered Mars orbit at a speed of 19,300 kilometers per hour, far too fast for a safe landing. Attempting to land a larger spacecraft capable of carrying humans presents even greater challenges and dangers, requiring specialized rocket engines and landing legs. The surface of Mars is largely covered in dust. Massive dust storms can create clouds that block sunlight. During such storms, conditions on Mars can resemble midnight for as long as 2 months. If humans were to live on Mars and rely on solar panels for energy, survival could be impossible due to insufficient power to maintain warmth. The average surface temperature on Mars is minus 60 degrees Celsius, and during winter, temperatures can drop below minus 120 degrees Celsius. In summer, daytime temperatures may reach levels ideal for humans, but at night, they plunge to minus 73 degrees Celsius. In such extreme conditions, one might find temporary shelter in some of Mars's lava tubes, ancient caves formed during the planet's volcanic activity. Mars has a thin atmosphere, with a volume only 1% of Earth's. This presents significant challenges because Mars is half the size of Earth, and its gravity is too weak to prevent atmospheric gases from escaping into space. What remains on Mars is primarily carbon dioxide, which accounts for 96% of the atmosphere. This gas is abundant, but highly toxic to humans in high concentrations. If you attempted to breathe on Mars without a spacesuit providing oxygen, you would die instantly from asphyxiation. Even if oxygen was available, the low atmospheric pressure would cause your blood to boil, making death inevitable. Elizabeth Haar, an assistant professor at the University of Nevada, USA, is receiving support from NASA for her research on developing snow algae, a type of algae commonly found in the Nevada desert and other low-nutrient, high-altitude environments on Earth. Under Mars-like conditions, the idea is to grow algae in greenhouses made of flexible materials similar to spacesuit fabric. The test algae are thriving well. Growing algae in such conditions not only produces food, but also generates oxygen. However, this research is still in its early stages, and scientists still need to address the challenge of ensuring a sufficient water supply for human survival on Mars. Victoria Hamilton, a planetary geologist at the Southwest Research Institute in the USA, notes that the red planet has layers of subsurface ice that could serve as a water source. A future Mars mission would need to use radar to map their distribution. Unless you only plan for a one-way trip, humans traveling to Mars will need fuel for the journey back to Earth. Developing a method to obtain return fuel is the biggest technological challenge facing Mars explorers. Scientists point out that carrying fuel aboard rockets is not feasible due to its excessive weight. A viable solution is to utilize Mars's resources to produce fuel. This would first involve extracting water through electrolysis from hydrated rocks and subsurface ice, then combining hydrogen and oxygen to create rocket fuel. Sooner or later, you can trust that scientists will solve these problems. All species, including humanity, were born on Earth, but in the not-too-distant future, we will leave our home planet. One day, Earth will no longer serve as a safe haven for us. The destiny of humanity on Earth could face grave danger. A large asteroid may strike Earth as it did in the past, causing the extinction of dinosaurs and numerous species on a global scale. However, we ourselves could also turn Earth into an uninhabitable place, for instance, by releasing excessive CO2 into the atmosphere, leading to climate change. In a relatively short time, climate change could result in extreme weather events such as prolonged droughts and floods, making it impossible for people to live in disaster-prone areas. Population explosion, combined with the finite resources on Earth, makes exploring outer space seem like a solution to escape this predicament. Humanity has already begun to consider space colonization. The discovery of water on Mars and the Moon has further fueled the idea of colonizing other planets. Currently, humans are focusing on two types of space settlements: orbital space stations around our planet, or surface-based facilities on locations like Mars, the Moon, or other planets, depending on the circumstances. Space settlements may be built either on the surface or beneath it, depending on the conditions of the chosen planet. In 2010, the United States government launched a large-scale program with NASA to establish permanent human settlements beyond Earth's orbit. They are currently developing projects such as the Space Launch System, SLS, and the Orion spacecraft to send astronauts into orbit around Mars by 2030. Commercial companies like SpaceX are developing the Starship rocket, which they claim will one day enable astronauts to travel safely to Mars and return. Human exploration presents far greater challenges and dangers compared to robotic missions. We need to launch heavy vehicles from Earth, provide living environments during the journey, and generate propulsion to accelerate travel, as the journey could take years. Additionally, cosmic radiation and solar flares pose significant risks to astronauts. Overall, reaching the Moon is easier due to its shorter distance, quicker return trips, and the fact that we already know a great deal about its conditions. In 2016, the director of the European Space Agency publicly presented a bold idea called the Moon Village. This is not just a project, but an open and inclusive concept welcoming everyone. The Moon Village could serve as an industrial area, a public hub, and a platform for activities involving both robots and humans. The Moon Village is envisioned not only as a research station, but also as a prototype for future space settlements and a waypoint for further missions. It will serve as an ideal testing ground and a starting point for all other missions into more distant regions of the solar system in the future. Building and establishing long-term settlements on other planets presents a completely different set of technical challenges compared to constructing orbital stations like the ISS. To succeed, all space settlements will require sources of water and food, transportation, energy, construction materials, equipment to protect humans from radiation, life support systems, and communication networks. Plants play a critical role in the survival of space settlements. On one hand, They will convert carbon dioxide exhaled by residents into oxygen through photosynthesis. On the other hand, they can be used as a source of food. Solar power can also be utilized to provide energy for lunar settlements. This energy comes from the sun, a massive fusion reaction that never stops. At Earth's orbit, the sun provides 1,000 to 1,377 kilowatts per square meter, continuously, forever, and it is entirely feasible to harness this energy. Mars, on the other hand, is much farther from the sun, resulting in significantly lower light intensity that reduces the efficiency of solar panels. In addition to surface-mounted solar panels, space settlements can receive energy from large solar satellites through wireless power transmission, such as via laser beams. This technology is particularly important because surface-based space settlements will rotate with their parent planet, meaning there will be times when they cannot receive sunlight to generate energy. A night on the Moon lasts 2 weeks, while on Mars, dust storms often block the already rare and weak sunlight. These storms also cause wear and tear on solar panels. Another proposal is to use nuclear energy as an alternative, but it carries significant risks. Securing a reliable energy source is not the only challenge. Transportation to extraterrestrial bases is also a complex task. Earth's gravity is the biggest obstacle when it comes to transporting goods to distant points in space. The cost of exploration missions is heavily influenced by the expense of launching rockets from Earth's surface into space. Therefore, to exploit extraterrestrial territories, we will need to develop new transportation systems and find ways to mitigate or reduce the impact of rocket launches on our planet's atmosphere. Equally important is transportation within space settlements. On the Moon or Mars, astronauts will need vehicles to assist with movement in low-gravity environments. You would also need to walk or work overtime in specialized astronaut suits. These spacesuits serve as shields against radiation and prevent changes in temperature and pressure. Another critical factor is the method of communication. For settlements on the Moon or in Earth's orbit, communication poses no significant issues, since most of today's communication is transmitted via satellites. However, for more distant territories, communication will become a serious challenge. Sending and receiving signals to and from Mars is relatively slow due to the distance, which increases the time it takes for messages to travel. The distance also varies greatly depending on the relative positions of Mars and Earth in their respective orbits. On Earth, the atmosphere enables us to breathe easily. This would need to be recreated in potential space settlements using complex technologies. Additionally, living spaces in extraterrestrial environments would be extremely limited due to the harsh external conditions that are unsuitable for normal human living. You would only survive with a fully equipped and meticulously prepared life support system. Conducting a relatively short mission with a focus on scientific exploration before returning to Earth might make things slightly easier. However, if you aim to establish a long-term and sustainable life with others on a new planet, you must find ways to solve these problems. To date, one unresolved challenge remains. We still cannot protect ourselves from radiation in the same way Earth shields us. Space is a boiling vat of radiation, a dangerous nuclear reactor. Radiation originates from two sources: cosmic rays coming from all directions simultaneously, and solar radiation. In the long term, humans cannot survive unprotected in outer space. Unlike Earth's surface, the Moon and Mars lack strong magnetic fields and thick atmospheres to provide natural protection. This reality not only affects life on potential planets, but also impacts long-duration space journeys. Spacecraft will require protective shields made of water or other materials capable of absorbing large amounts of radiation. However, living on the surface of these planets will also necessitate specialized protective equipment. Setting aside these concerns, long-duration space travel poses significant health risks for humans. With current technology, it takes 2 days to reach the Moon, but traveling to Mars is much farther, requiring 6 to 10 months. Astronauts would need to live in the confined conditions of a spacecraft for an extended period, which can have detrimental effects on their health. Extraterrestrial missions. Long-term missions beyond Earth can also lead to psychological and social issues. The feeling of isolation in space can cause space syndrome and depression among crew members. Sleep deprivation or monotony may lead to errors in tasks that require absolute precision. Prolonged space travel can result in bone loss, reduced red blood cell production, cardiovascular dysfunction, vision problems, weakened immune system function, and other challenges. Despite these difficulties, it may not be long before humans take their first steps toward settling beyond Earth, our home planet, which is currently the only home we know. These pioneers will be the first to prove that humanity can survive and thrive in the vast universe. How would the human body change if settling on Mars? Mars is considered an ideal planet for human migration into space, but its environment is extremely harsh compared to Earth. This would have profound effects on the human body. So, if we were to settle on Mars, what challenges would humans face? Let's explore together. Extremely high radiation levels. According to data recorded by the Mars Odyssey spacecraft, radiation levels on Mars are significantly high, approximately 250 millisieverts per year. To put this into perspective, this is much higher than the annual limit for workers in nuclear power plants in the US. It is estimated that within 2 years, a person living on Mars would be exposed to 6 times the permissible radiation levels by current standards. With such high radiation exposure, without effective protective measures, the DNA of those living on Mars would mutate, leading to cancer. Additionally, the process of evolution could accelerate due to the creation of random genetic mutations, some of which might prove beneficial. However, the human brain, memory, and behavior would also be severely affected by high radiation levels. Natural selection, though, might filter out weaker individuals and foster a healthier, stronger generation in the future, one capable of exploring even harsher and more distant planets. Accelerated aging of the body. Gravity plays a crucial role in maintaining bone tissue, bone function, and overall cellular health. Living on the red planet, where gravity is much weaker than on Earth, would result in significant bone tissue loss. This means residents of Mars would not only be more prone to fractures, but they would also experience rapid bone density loss at an alarming rate. Bone density is expected to decrease by 1 to 2% per month, and within 2 years, residents could lose nearly half of their bone density. Women, in particular, face a faster rate of decline as they require a larger amount of calcium to maintain their bones. This results in premature aging of the skeletal system, which likely begins with the bones but certainly does not end there. A study in 2021 revealed exposure to space radiation causes errors in DNA replication, introducing another issue that accelerates aging in astronauts. If you live on a planet like Mars, your heart may become weaker, increasing your risk of heart attacks, or, at the very least, significantly elevating your chances of developing heart disease. A report by the University of San Francisco in the United States indicates that prolonged exposure to outer space generates highly toxic substances for the human cardiovascular system. This is due to a harmful combination of radiation and microgravity, which makes it harder for the circulatory system to perform its functions. Additionally, the left and right ventricles of the heart will lose mass, likely due to a reduction in blood volume and cardiac muscle. Astronauts' heart rates in space are lower than on Earth. For instance, on the International Space Station, ISS, their heart rate is similar to the resting state on Earth before a flight. Blood pressure in space is also lower than normal. The circulatory system, heavily influenced by gravity on Earth, adapts to pump blood against gravity, such as through veins in the legs that return blood to the heart. In space, however, the absence of gravity eliminates these effects. The shape and size of blood vessels and the heart itself can change. According to Dr. Malin Grennan from Harvard Medical School, low-gravity simulations suggest that living in a microgravity environment can even alter how certain genes are expressed in cells, particularly those involved in cardiac electrical conduction. Changes in these cells may increase the risk of arrhythmias. Living in a microgravity or low-gravity environment makes it easier for the body to pump blood. However, this is not necessarily beneficial for the body. It causes the heart to gradually become lazier and less healthy over time. The immune system, which protects the body from illness, is also affected by the space environment. Several factors contribute to this, including radiation, microgravity, psychological stress, loneliness, changes in circadian rhythms, and altered sleep cycles. Additionally, living in space or on Mars leads to isolation, and prolonged exposure to bacteria from your own body or other crew members may alter their immune systems. The risk of infections increases significantly in space, where you might also be exposed to extraterrestrial pathogens. Physical endurance is often measured by the maximum oxygen the body can utilize during exercise. The aforementioned changes in the circulatory and musculoskeletal systems contribute to a decrease in physical endurance. A previous study showed that after just 14 days in space, the maximum oxygen consumption by the body drops by 20 to 25%. However, after about 5 to 6 months in microgravity, the numbers begin to improve, indicating that the body shows signs of adaptation. Despite this, the body never fully returns to its original state, as it was on Earth. Beneficial microorganisms, such as gut probiotics, play an essential role in human life. On Mars, children would lack exposure to these beneficial bacteria, leading to disadvantages like poor metabolism, reduced immunity to common diseases, and a higher risk of developing type 1 diabetes, asthma, allergies, and certain cancers. Without these beneficial bacteria, humans on Mars would only be able to digest certain simple sugars, proteins, and fats. On Mars, there is no thick atmosphere to shield against strong cosmic radiation, resulting in a significantly increased cancer rate. However, mutations could serve as raw material for the process of evolution. If humans can survive, the high mutation rate would mean a more diverse genetic pool in the future with each generation. Of course, this would not happen within a single generation, but these mutations could become significant over time. Mutations are entirely random, but this randomness leads to the separation of species. In reality, with a new and extremely harsh climate, natural selection would favor genes that provide individuals with a survival advantage over others. While mutation and evolution into a new species may seem alarming, it is not necessarily a bad thing. It is certainly better than inbreeding, which poses a major risk to small populations of humans living on Mars or elsewhere in the universe. With a small population, inbreeding becomes a concerning threat. This raises the critical question: how will we prevent inbreeding in such isolated environments? If you cannot increase the population size, you will need a family planning strategy to pair individuals with the greatest diversity. Strict regulations would have to be established regarding partner selection for everyone. From the moment humans first appeared on Earth, we have looked to Mars in the night sky. Over time, we studied the red planet using telescopes and satellites. We have driven rovers across its surface and even discovered signs that ancient life might once have existed there. Today, humanity hopes that we will eventually be able to live on Mars despite its harshness and challenges. Mars is a planet of striking contrasts. The largest volcanoes in the solar system, deep valleys, and breathtaking landscapes. In the future, it could become an incredible destination for tourists. Today, we'll introduce 8 must-visit destinations for your trip to Mars. Olympus Mons. The giant volcano. Olympus Mons is the most extreme volcano in the solar system, located in the Tharsis volcanic region. Its size is comparable to the state of Arizona in the United States, with a height of 25 kilometers, nearly 3 times the height of Mount Everest on Earth. Olympus Mons is an enormous shield volcano formed by lava flowing down its slopes. This formation also means that the mountain is relatively easy to climb, as its average slope is gentle. The summit boasts a spectacular crater, about 85 kilometers wide, formed by collapsed magma chambers, possibly after an eruption. The Tharsis volcanic region. While ascending Olympus Mons, travelers can also admire several other volcanoes in the Tharsis region. According to NASA, Tharsis contains 12 massive volcanoes within an area roughly 4,000 kilometers wide. Like Olympus Mons, these volcanoes are significantly larger than those on Earth, likely due to Mars' weaker gravitational pull, which allows volcanoes to grow taller. These giant volcanoes may have erupted in Mars' geological history. The image above shows the Tharsis region, captured by Viking 1 in 1980. On the left, from top to bottom, is the colossal Olympus Mons, while to the right and below are 3 towering shield volcanoes, Ascraeus Mons, Pavonis Mons, and Arsia Mons. Valles Marineris, the Great Canyon. Valles Marineris is another breathtaking natural wonder on Mars, stretching across the planet's surface. This vast canyon system, believed to have formed from tectonic activity, offers an unparalleled view of Mars' dynamic geological past. Mars not only boasts the largest volcano in the solar system, but also the largest canyon, Valles Marineris, which stretches approximately 3,000 kilometers, about 4 times the length of the Grand Canyon in the United States, which is 800 kilometers long. Researchers are unsure how Valles Marineris was formed, but there are several theories about its creation. Many scientists believe that the formation of the Tharsis region contributed to the development of Valles Marineris. Lava flowing through the volcanic region may have pushed the crust upward, causing it to crack. Over time, these cracks expanded into the vast canyon system of Valles Marineris. The most fascinating aspect of Valles Marineris is that if you stand there and watch the sunset, it would appear blue rather than red. This is because Mars's atmosphere is very thin. The light waves reaching your eyes are scattered by air molecules, creating the image of a blue sun, especially near the end of the day. Mars has 2 icy polar regions with slightly different compositions. The northern polar cap, studied up close by the Phoenix lander in 2008, contrasts with observations of the southern polar cap, which have been conducted via orbital spacecraft. During winter, temperatures near the poles become so cold that carbon dioxide condenses out of the atmosphere into surface ice. This process reverses in the summer, when CO2 sublimates back into the atmosphere. In the northern hemisphere, all the CO2 ice disappears, leaving behind a permanent water ice cap, whereas some CO2 ice remains in the southern hemisphere. These movements of ice have a significant impact on Mars's climate, generating winds and other atmospheric effects. Gale Crater gained fame following the landing of the Curiosity rover in 2012. This crater holds evidence of past water activity. Within weeks of its landing, Curiosity discovered a stream bed and has since found numerous other significant signs of water, during its journey across the crater floor. Currently, Curiosity is exploring a nearby mountain called Mount Sharp, or Aeolus Mons, analyzing the geological features of its various strata to uncover more about Mars's past environment and its potential to have supported life. One of Curiosity's most intriguing discoveries is the repeated detection of complex organic molecules in the region. In 2018, NASA announced findings showing these organic compounds were found inside 3.5 billion-year-old rocks. Alongside these results, researchers also revealed that the rover detected seasonal variations in methane levels in the Martian atmosphere. Methane is a compound that can be produced by both microbial life and geological phenomena, raising the possibility that it could be a sign of life. Medusae Fossae is one of the most mysterious locations on Mars. Some speculate that its terrain might be the result of a UFO crash. However, a more plausible theory suggests it is a vast volcanic deposit, with an area comparable to the size of the United States. The volcanic activity has shaped the rocks here into breathtaking forms. Further research is needed to understand how these volcanic features were created. A 2018 study proposed that Medusae Fossae may have formed from massive volcanic eruptions occurring hundreds of times over a span of 500 million years. These eruptions likely warmed Mars's climate by releasing greenhouse gases into its atmosphere. Mars is home to unusual geological features, known as recurring slope lineae, RSL, which tend to form on steep crater walls during warm weather. However, identifying these RSLs has proven difficult. Images from the Horowitz crater show areas where spectral data detected signs of hydration in 2015. Initially, NASA announced that hydrated salts must indicate flowing water on the surface. Later studies, however, suggested that RSLs might be formed by atmospheric water or dry granular flows. In theory, we could examine these RSLs up close to determine their nature, but this poses a challenge. If they contain alien bacteria, there is a risk of contamination. Future Mars explorers may need to observe these enigmatic formations from a distance using binoculars. Today, Mars is primarily shaped by wind, as its water has mostly evaporated due to a thinning atmosphere. However, there is ample evidence of past water activity, such as yardangs, streamlined rock formations found in regions like Noctis labyrinthus and Hellas Basin. Researchers suggest that these areas once featured sand dunes several tens of meters tall. These dunes were later submerged by lava or water, preserving their bases while their tops eroded. These ancient sand formations provide clues about how winds shaped ancient Mars, offering climate scientists valuable insights into the planet's past environment. In a surprising twist, bacteria might be hiding in sheltered areas within these dunes. The formations protect them from radiation and prevent them from being swept away by the wind. Don't miss the opportunity to observe our home planet from afar. Imagine escaping daily worries by lying on Mars's surface and gazing at Earth. From there, our planet would appear as a small, bright dot in the sky, encompassing all of humanity, much like how Venus greets us each morning from Earth. New agricultural methods on Mars to support sustainable life. In recent times, there has been an explosion of information about NASA's and Elon Musk's missions to send humans to Mars and establish settlements there. These initiatives have garnered significant public attention. However, there are numerous challenges to be addressed to achieve this mission. One of the critical issues is how humanity can live sustainably and long-term on Mars, given its barren surface unsuitable for agriculture. Recent research efforts by scientists have uncovered groundbreaking solutions to tackle these challenges. Billions of years ago, Mars was a planet with flowing water, strong winds, and rainfall under cloudy skies, much like Earth. At that time, Mars was essentially no different from Earth, except for one significant factor. Its diameter was only half that of Earth. This means its overall volume was also significantly smaller than Earth's. Larger planets like Earth have more material and internal heat, enabling them to retain heat for longer periods. In contrast, Mars, being smaller, has less internal heat and a larger surface area relative to its volume, which means it could lose heat to space faster than Earth. Additionally, like Earth, Mars may have once had a magnetic field generated through a process called geodynamo. This process occurs when the metallic liquid core of a planet, primarily composed of iron and nickel, moves and circulates. The motion of these conductive liquids generates electric currents, which in turn produce the planet's magnetic field. However, for this geodynamo process to operate, the planet's core must remain partially liquid. On Earth, the movement of the molten outer core generates our magnetic field. On Mars, due to its smaller size and lower mass, its core cooled and solidified faster than Earth's. As the Martian core cooled and solidified, convection of liquid metals ceased, halting Mars's geodynamo activity and causing the planet's global magnetic field to disappear. Without a magnetic field, Mars became vulnerable to solar wind and streams of charged particles emitted by the Sun. These factors gradually stripped away much of Mars's atmosphere over millions of years. This process thinned the Martian atmosphere, rendering it incapable of retaining heat or liquid water, contributing to the cold and arid environment we observe today. In addition, relentless radiation combined with static discharges from planet-wide dust storms has driven chemical reactions in the dry soil of Mars, ultimately making it rich in unpleasant, toxic salts known as perchlorates. According to science fiction filmmakers, farming on Mars is entirely feasible. In the movie The Martian, the protagonist, Mark Watney, constructs a greenhouse, processes waste for fertilizer, irrigates crops, and waits for the harvest. The film includes many accurate depictions, such as the use of human gut bacteria in soil microbiomes. However, it completely omits perchlorates. With the presence of these substances, the potatoes grown by Watney would never have developed. Even if they did, consuming contaminated potatoes for 2 years would damage the thyroid gland, harm the kidneys, and destroy retinal cells due to perchlorates' inherent toxicity as a neurotoxin. So, what exactly are perchlorates? This substance was first discovered by NASA's Phoenix lander in 2008. Subsequent missions by the agency confirmed their presence in significant amounts on Mars. Specifically, Martian regolith contains approximately 0.5% perchlorates by weight, which is substantially higher than the trace amounts typically found on Earth, measured in parts per million. This presence of perchlorates on Mars poses significant challenges for human colonization, as these compounds are toxic to humans and plants, inhibiting crop growth and requiring removal to create safe soil for agriculture. From a chemical perspective, perchlorates are compounds containing the perchlorate ion, ClO4, consisting of one chlorine atom bonded to 4 oxygen atoms. Perchlorates are usually salts that combine this ion with a positively charged ion, such as sodium, potassium, or ammonium. These compounds are highly soluble in water and can be found both naturally and as a result of human activities. The United States extensively used perchlorate compounds during World War II and later utilized large quantities of related chlorinated organic solvents in various industries, including dry cleaning, metal degreasing, dye production, textiles, and pharmaceuticals. At that time, industrial waste management practices were lax, leading to widespread groundwater contamination across the nation. It was only after the Clean Water Act and other environmental protection regulations were enacted in the 1970s to restrict or ban certain hazardous chemicals that Americans became aware of the severity of this pollution. There are several ways to remove perchlorate compounds. Rain and artificial irrigation systems can wash these compounds away, but this only pushes the perchlorates into groundwater. Another solution is planting woody plants, such as willows and poplars, in contaminated areas. These plants absorb perchlorates from the soil, and they can then be removed from the environment. Another viable solution is heating perchlorates to a high temperature of about 400 degrees Celsius to break them down into harmless byproducts. However, this method requires significant energy, akin to nuclear reactions, and involves extensive auxiliary equipment. The final and most feasible solution is bioremediation using microorganisms, as certain microbes can metabolize perchlorates, breaking them down into harmless ions and oxygen. Perchlorates are indeed a major issue that NASA and Elon Musk must address in their space missions. For the Artemis program to establish a long-term human presence on Mars, or for Elon Musk and his vision of creating a human civilization on Mars, this issue must be resolved thoroughly before any spacecraft can depart from Earth. Agriculture, in particular, poses a significant and practical challenge for scientists. The surface of Mars does not contain soil, but rather regolith, a toxic and dusty mixture of loose rocks and sand that forms the planet's surface. Regolith cannot support plant life, while humans need food for sustainable living. Therefore, agriculture is essential for producing food. To cultivate crops on Mars, one cannot simply plant seeds, water them, and wait for them to grow. The first step is creating a soil layer that can support life by removing perchlorates and enriching the regolith. Various methods for removing these salt compounds, including burning or washing them, exist, but require vast amounts of energy and resources, making these approaches impractical. One feasible alternative is Earth becoming the source of food supplies. While storing food on spacecraft and sending it to Mars seems like a simple solution, missions from Earth to provide food for Mars settlers are unsustainable in the long run. Relying on Earth-based resupply compromises independence. Humans need to farm on Mars rather than depend on constant shipments from Earth. Moreover, Earth resupply missions are limited and expensive, as they demand significant resources. Every kilogram of food sent to Mars increases mission costs and complexity. Spacecraft have limited space, most of which must be reserved for essential equipment, fuel, and life support systems. As time spent on Mars increases, the required food supply grows substantially, making resupply from Earth unfeasible, especially in scenarios where delays or mishaps disrupt resupply missions, directly impacting the settlers on Mars. Another solution NASA has considered is hydroponics. Essentially, hydroponics is a method of growing plants without soil, using nutrient-rich water as a substitute. This appears to be a potential solution for growing food on Mars, but it also has limitations, particularly when it comes to supporting large populations or transporting the system from Earth to Mars. Hydroponic systems require specialized equipment, such as pumps, lights, and climate control systems, which must be constructed on Earth and then transported to Mars. This makes them energy-intensive and complicated to transport. They also require constant monitoring to prevent bacterial or fungal contamination. If the system becomes infected, the entire crop can be destroyed because it is a closed system. This means water and nutrients are recirculated, allowing contamination to spread rapidly. In such cases, everything would have to be discarded and rebuilt, which is costly in terms of time and resources. Ultimately, hydroponic systems can only comfortably support small groups of around 10 to 15 people. Scaling up hydroponic systems to sustain larger populations on Mars would be extremely challenging due to the high energy and equipment requirements. This is why hydroponics is seen as a short-term solution for small groups, but not a scalable option to support large populations over the long term. For these reasons, NASA and other space agencies are aiming to make Mars missions more self-sufficient. If astronauts on Mars remain dependent on resupply missions from Earth, they will always face risks of supply chain disruptions. Achieving independence from Earth is a key objective in establishing a long-term human presence on Mars. The only sustainable long-term solution is to cultivate Martian soil. However, to achieve this, the problem of perchlorates must be resolved. Once Martian soil is treated to make it suitable for agriculture, it could provide a sustainable and scalable source of food for larger populations. This approach would be more sustainable than the alternatives mentioned earlier. The ideal solution at this point is no longer heavy, large-scale machinery. Instead, the focus has shifted to extremely small-scale solutions. Microorganisms. NASA and numerous organizations have funded research to find ways to remove perchlorates from Martian soil and develop agricultural methods for it. However, the biggest challenge is that humanity does not yet have an actual sample of Martian soil. Over 5 decades of NASA's Mars-related missions have attempted to accomplish this, but have all failed. As a result, scientists have been forced to find alternative approaches to solve this problem. Among the research teams funded by NASA, 2 groups are making significant progress. The Biodesign Institute at Arizona State University, ASU, and the Florida Institute of Technology, each playing a different role in this mission. The research team at ASU is tasked with figuring out how bacteria can remove perchlorates from Martian soil. To achieve this, scientists are using a type of simulated soil resembling Martian soil, based on the chemical composition data sent back by the Curiosity rover. This compound, known as Mars Global Simulant MGS-1, is created by a company called SPARTAN Technologies. This simulated soil is very fine, similar to beach sand, and resembles cocoa powder in appearance. Using this soil, scientists immerse it in nutrient solutions with bacteria. They also introduce perchlorates in the form of white powder into test tubes, effectively creating a miniature Mars environment inside the lab. The bacteria then consume the undesirable substances, leaving behind what they don't prefer. This method allows scientists to identify the ideal combination of microorganisms to remove perchlorates. Additionally, the researchers aim to make this process as efficient as possible. They hope that, after processing perchlorates, the bacteria will produce chloride and oxygen as byproducts. The oxygen generated through these reactions is expected to be significant, and the team is exploring ways to capture and utilize this oxygen. The principle is straightforward. Perchlorates contain oxygen molecules in their structure, and these salts exist in large quantities on Mars. If humanity succeeds in processing perchlorates, a significant amount of oxygen could be produced for use on Mars. This would be a major breakthrough, as producing oxygen locally would reduce dependence on Earth supplies and enhance the sustainability of long-term Mars missions. Another issue the scientists are addressing is how to transport these microorganisms to Mars. They suggest that large containers may not be necessary, as astronauts themselves already serve as natural carriers of billions of microorganisms in their gut. The research team has also experimented with removing perchlorates using bacteria derived from sludge collected from wastewater treatment plants. This aligns with the method used by the protagonist in the movie The Martian, which is somewhat on the right track. One challenge scientists must overcome is the potential existence of natural enemies to these microorganisms on Mars that could hinder their activity. Currently, regolith is being prepared and treated in small-scale experiments at ASU's lab. The research team has successfully reduced perchlorate concentrations from approximately 1 gram per kilogram to as low as 1 milligram per kilogram, or even lower. This concentration, theoretically, would no longer inhibit seed germination. For perspective, soil in the Arizona desert has perchlorate concentrations ranging from 0.3 to 1 milligram per kilogram, while in the Atacama Desert, the concentration can reach up to 1 milligram per kilogram. The results achieved by the research team are promising for the missions NASA envisions. However, removing perchlorates alone is not sufficient for plants to thrive on Mars. Andrew Palmer, Associate Professor of Biology at the Florida Institute of Technology, stated that even after removing perchlorates, there remains the challenge of converting Martian regolith into arable soil. This problem ties into a larger question. How can we ensure a sufficient food supply on Mars? Food security is a significant concern for Mars missions. With a travel time of 6 to 9 months from Earth, if food supplies are lost, humans would not survive until the next resupply. Therefore, agriculture is a critical challenge that humanity must address. To tackle this, researchers have started growing fungi and bacteria in Martian regolith simulants to explore ways to transform the regolith into soil suitable for plant growth. The simulated soil, provided by scientists at ASU, is used by Palmer for his experiments. Essentially, soil is a substrate influenced by biological processes. In the simulated Martian regolith, or in real conditions, bacteria responsible for removing perchlorates can also alter minerals and release other beneficial nutrients for plants, such as potassium and phosphorus. Additionally, this process can be used to introduce other nutrients into the soil. Palmer's team is working to turn this into a complete ecological cycle. They use a semi-controlled environment called the Red House, which features artificial lighting and environmental controls. The plants grown there have never been exposed to sunlight. This setup simulates actual Martian conditions, where there is no atmosphere and temperatures are colder than Antarctica. The plants are cultivated in a closed system controlled by artificial light. In this room, the team has been growing various plants to observe the regolith's evolution over time. They have successfully grown lettuce, arugula, bell peppers, tomatoes, and clover. Next, they plan to experiment with peanuts. This project is still in its early stages, so no conclusive results are available for the researchers to share yet. However, one positive sign is that growing plants in the simulated soil makes its structure more porous, which is beneficial for plant growth. Researchers at Arizona State University and the Florida Institute of Technology have succeeded in reducing perchlorate concentrations in regolith samples. They have also made progress in increasing the organic matter content of the soil used in their experiments. Essentially, scientists involved in this project have altered the structure of the regolith and begun cultivating plants in it. The next step is to do all of these processes simultaneously. When successful, this will pave the way for humanity to sustain itself, first on the red planet, and eventually beyond into the universe.